Dear students, today we will start new module matter in our surroundings. So we'll start about this matter in our surroundings. So let us see. In this universe, everything is made up of materials called matter. So matter is everywhere we have around us, including our body is made up of matter. So matter is there around us, the solids or liquids or gases, whatever we see in our day-to-day life, everything is made up of matter. So when we see properties of matter, then what is matter made up of? So matter is made up of small tiny particles. So when these all tiny particles come close to each other, then matter is something which exists or which forms. So what is matter? Matter is something which occupies space and has mass. It is considered to be matter. So anything which occupies space and has mass is called matter. So one important thing is the particles which are involved in the matter, they will be continuously moving. So the particles which are there in the matter, they are in the continuous movement. Let us see some more properties of matter we can see. So the first thing is, as I said, the particles which are involved or which are there in the matter, they are very small or very tiny. If you isolate one particle and if you isolate and you want to observe with your naked eye, we cannot see this particle. So it's so small. And the particles which are there in matter, they have some million trillions of particles will be there, and between them there is something called intermolecular space will be there. So the space is something which is there between the particles which are there, which are present in the matter. And the particles which are present in the matter, they will be moving randomly in all the directions. So the particles which are there, the continuous movement is something which is observed. And the particles of matter, actually they attract each other. The attractions between the particles in the matter which can be seen. So these attractions are there, and these attractions only we termed as, or we named as, intermolecular attractions. So there are intermolecular attractions which are working between the particles in the matter. Let us do some activities which proves some of the properties of the matter. The first property is we say that the particles of the matter are very tiny. So to prove this, what we are doing is we are taking one beaker. In this beaker, 100 ml of water I am taking. Then in this, 2 to 3 crystals of KMnO4, which is potassium permanganate, adding here. Then obviously the solution becomes a purple color. Then when I take 10 ml of this solution and add in another beaker in which only water is there, that solution also becomes light purple color. Then from this light purple color solution, again I take 10 ml solution and I add into another beaker which contains only 100 ml water. So that also becomes the colorful. It will be a pinkish color. Then again when I take 10 ml from this and again I add into a plain water beaker, again it is forming light pink color. So that means the imparting of color, or color you can see here in all this, even that means I am diluting it so much. I am taking first 100 ml, in that some KMnO4 I added. Again from this solution I took 10 ml, I added in only water, so I diluted. Again I diluted in another, from this into 10 ml I took and added in another plain water beaker. So here still color is something which is importing, or it is, you can see here color is something which is exhibiting by all these solutions. That proves that whatever extension I am 5 to 6 times I dilute, still that color is there. That means the particles of matter are very very tiny, and they are spreading across. And these tiny particles, because of there only 2 to 3 crystal added in 100 ml, then again I diluted so much, still that is there, which proves here the particles of matter are very small, very much tiny. So when I take this 2 to 3 crystals of KMnO4, it has some millions of KMnO4 particles so that particles are getting spreaded. So that's how it is happening here, you can see. So let us see another activity, that is how do we prove that there are intermolecular space present between the particles in the matter. So to prove that, one more activity we are doing, that is I'm taking a beaker. In this beaker I am taking a water, and after once I take water, I am marking the level of water in this beaker. Then in this I am adding a pinch of salt, or a spoon of tablespoon of sugar I am adding, or you can add both actually, a pinch of salt as well as a tablespoon of sugar, both I am adding. Then I am taking a glass rod, and then I am stirring it very well so that it mix properly. So after mixing, after adding this salt and sugar, one thing surprisingly, when I see the marking level which I have done, water marking level, that marking level has not increased. In fact, I added matter, salt added, sugar added, still that marking level is not increasing. That means where that salt and sugar is going then. So when you add extra matter, the level of water should increase, the solution level should come up. It is not happening. So which proves here that the sugar particles or the salt ion particles, they are occupying the spaces which are present between the water molecules. So here intermolecular space between the water molecules, there are so many trillion millions of water molecules in this. So in between the water molecules, H2O molecules, you have space. In that space is something where salt and sugar is occupied, due to which here the level, marking level is something which is not increasing. So this is one of the best activity. We can in fact do this at home also. Let us see one more activity which proves the particles in matter are continuously moving. For that, what I am taking is, I am taking one beaker in which some amount of 100 ml of water is taken. Then I am adding 2 drops or 3 drops of blue ink or red ink. Then what I am doing is, I am, without disturbing this ink solution, I am keeping it aside for some hours. Then what is happening is, the ink which 2 to 3 drops of blue or red ink which added, it is evenly getting distributed throughout the solution, and it is becoming a blue color solution or it is becoming a red color solution, depends which one we add. When I add red color ink, it is becoming red color solution. When I add blue color ink, it is becoming a blue color solution. So now here what is happening, the intermixing of ink particles and water particles taking place, due to which the solution is becoming colorful solution. So evenly it is getting distributed. So that is the intermixing of 2 or more different types of matter. When it is happening by its own, this is something which we call it as diffusion. Diffusion is very common in especially gases, the intermixing of gases, especially when even when we are cooking and all. Also we see here when we cook in kitchen, that aroma, that fragrance and that smell is something which we can feel when we are in the living room or when we are in the bedroom. So that is all because that the diffusion is something which is happening. So here let us see one more activity, that is how intermolecular attractions are working, or to prove that intermolecular attractions are working between the particles in the matter. So we can see here what taking is, we are taking the 3 different matter. One is iron nail, another one is piece of chalk, and other one is one rubber band. Then trying to bang these 3 matter, 3 states or 3 different matter by taking a hammer. So when we hit hard on these 3 matters, that is iron nail and piece of chalk and a rubber band, surprisingly the iron nail which is there, it will not get broken so easily. So you cannot break it so easily. Why we are not able to break? Whereas a piece of chalk, when it is there, just you with one hit with a hammer, it breaks into pieces. So whereas the rubber band which is there with some 2-3 times when we bang, then it also breaks. So here, why this is happening, all are solid matter only, then why it is happening means we can say here, this is because the iron nail, between the iron particles, in iron nail there are so many million trillion iron atoms are there, between the iron particles there are strong intermolecular attractions are working, so it is very difficult to separate them. You need more energy or more force to separate the iron atoms here, so breaking is difficult. Whereas when I see the piece of chalk here, whatever the carbon atoms are there, in carbonate atoms, carbon atoms are there, breaking is easy for me because the intermolecular attractions between them are not very strong. So intermolecular attractions plays very big role.